Hey, what's up, guys? This is part 2 in the Getting Practical with Typescript series. In this video, we're going to be talking about creating types for functions, and then we're going to get practical with creating a implementation of a map. We're going to create a very basic implementation, but it will tie together the things that we've learned in the first and in this part. So let's get started. So first of all, let's say we have a function called greet. And greet, all it does is take in a name, and it returns hello name. So if we take a look at this error right here, so parameter name has implicit any type. And like we mentioned in the previous video, we do not want things to have an any type, because then there's no difference between this and JavaScript, and it turns into the Wild West. So in order to annotate or to add a type to a parameter in a function, all you do is very similar to a regular variable, is add a colon and then string. So that way, if we now go greet 12, you'll see we have an error here that says number is not assignable to string. But if we add Jacob, and then we write in the console over here npx ts node2.ts. So we'll see once it compiles and loads. I'm not sure why it's taking such a long time. Because we didn't write console log. So console.log greet Jacob, and it should run a bit faster this time. So hello Jacob. Cool. So this is an example where we're also implicitly allowing the function to return string. Some people prefer to add the explicit annotation to make sure things don't change. It's a matter of preference. You can leave it here for now. The same thing would be is function get favorite number, which could just always return 12. It implicitly has a return type of number, but you can explicitly add it if you'd like. Okay, so the next thing that we'll do is create a new array of names, which are going to be Jacob, Alice, and Bob. So TypeScript already knows that this is a string array, but for this course I'm going to be adding in explicit type annotations, just so that we can get used to typing in the annotations. And now let's say like this, names dot for each. So we have a name. I can say name dot to uppercase. Well, it already corrected us, but let's say if I didn't correct it, it already knows that name is a string, and we do to uppercase. So let's actually explicitly type everything. So let's add parentheses around name and add string, just like we saw over here. So the same thing holds true for arrow functions. So we have over here the string. Over here you can see we're returning a string as well. Really, for each doesn't make sense to return a string. So let's do that in a map. So let's say new names, and we'll just basically say names.map. We'll take in a name, and we'll always return Jacob. So we'll add the type string annotation, as well as add in the type string annotation here as well. And this will say we are always returning a string. And new names is going to be a string array, just like that. Okay, so the next thing I want to talk about is optional types. So let's say we have a user interface, user, and the user just has a first, which will be Jacob, and they can also have a last name. But, well, actually, let's do middle, which is, I don't have a middle name, so there is no middle name, and last name, and Beckerman. Okay, so the question is, not all users have a middle name. So how do we actually tell TypeScript that the middle name is not needed? So the way you do that is by adding a question mark before the colon, and Well, you see, I did this wrong here because I was already jumping to the implementation. If we look over here, it's the interface user. We've now said that first is always equal to Jacob. We don't want that. We want first to always equal string. We want middle to always equal string. And we want Beckerman last to always equal a string. The way we make middle optional is by putting a question mark over there. So if we look at user, const user, which is of type user, we can say first is Jacob and last is Beckerman. Okay, this is complaining because we have index over here. So let's just get rid of these guys for now. It's conflicting in our previous file. And let's get rid of this. Okay, so we have here a user, and you can see we can optionally add in a middle name. But since I don't have a middle name, I won't add that. If I remove this question mark from the interface itself, you'll see that middle is missing in type. Cool. So if I use this, for example, and say function print name, so we have a user, which is of type user, and we could say if user.middle, then we'll return user.first, user.middle, and user.last. Otherwise, we're just going to return user.first and user.last. Cool. Now, let's say we want a value to be equal to either a number or a string. It could be both. Sometimes we have an ID, which can be a number or a string. So that's something that's called a union type. So if we have a function print ID, it will take an ID. Now this is a string or a number. And this may look like an or, but it's not actually. It's basically a way of saying that the ID can be string. Really, it's or number, but it doesn't actually mean or. It's a union between these two types. So now if we say id.to uppercase, you'll see that won't work. And the reason for that is because to uppercase does not exist in type number, and this can be either of those IDs. Either of those types. So we actually need to narrow down the type. So we say if type of ID is equal to number, then we'll just return ID. Otherwise, we're going to turn id.to uppercase. And you can see that Typescript now is happy with that because we've narrowed the type down to string at this point, and over here it's string or number. Here we know it's a number already. Cool. So now that we have that done, let's erase all of this. Let's go back to our index.ts where we're going to do most of our work and create a map. Now the map is basically going to have the functionality of the JavaScript map where you can set an item, you can remove an item, and you can do all that stuff, but we're going to recreate it from scratch. But we're going to be making it specifically for the key is going to always be a number, and the value is going to be a user. So let's just say interface user. So user will have a first name, which is a string. They'll have a last name, which is always going to be a string. They have a middle name, which is, if they have a middle name, it will be a string. Now we're going to create a interface called user map, and it's going to have a property called users, which is going to be a record between a number and a user. Cool. We're going to have a set function, and this is something we haven't yet seen. You can add functions as interfaces, as types. So if we look at that looks like, we can say the set is going to be a function, and it looks like an arrow function, but it isn't quite an arrow function. So the set will take in as a parameter an ID, which is a number, and the user, which is a user, and it will return void, because we're not actually returning anything, and void is very similar to just saying it's going to return undefined. Now, we have a get function, which takes an ID, which is a number, and it will return either void if it does not exist in the map, or a user. And this is the union type that we saw again. We're going to have a delete, which takes an ID, which is a number, and we'll return void. And we will have a clear, which will just clear out the entire map. Okay. So now about implementing the actual functionality. So let's show something new that we'll learn over here is how to actually make a class, a JavaScript class, implement a interface. So we're going to say the class of user map, and we're just going to have to change this to iUserMap, which is just a prefix that's used to denote a interface, and we're going to say implements iUserMap. Cool. So this will have a constructor, and in here we'll say that this is going to have a property called users, and it's going to be equal to record number user. Now, we see over here that we need to actually make it equal to something to start off with, so we're just going to say it's equal to an empty object. Cool. If we hover over here, we'll see that we're missing set, get, delete, and clear. So let's create the set functionality first. Set will take an ID, which is a number. It'll take a user, which is a user. And we'll say this.users ID is equal to a user. Cool. We're going to have a get function, which is going to have an ID, which is a number. And it's going to return void or user. Sorry, you just have to add the 2 dots. And we're going to return this.users ID. Cool. And the delete will do a similar thing, ID number. And that auto-completed for me, but we want to delete, which will return void. And then we'll say delete this.users ID. And the last thing we'll do is clear. And clear will just say this users is equal to an empty array, or an empty object rather. Okay, so that's the basic implementation done, and now let's test it out. So if we say const map is equal to a new user map, we can say map.set 1 will be equal to a user where the first, and you can see that the type hinting is really useful, Jacob, and last is equal to Beckerman. Cool. We can also say map.get 1 and const result is equal to map.get1. Let's say map.delete 1. Let's copy this line over here and let's test this out. Let's just console log result 1 plus after delete. Just say after delete and comma result 1, and then say console.log before delete and result. Cool. So let's do npx ts node index.ts. And let's see what it says here. Always takes a little while to compile. But once it finally does compile, we should see before delete, first, last, and then after delete, so it is undefined. And you can see the real power of TypeScript over here is that we were able to just implement this without testing it throughout, because since we were using TypeScript, we just knew that it would work. All right, cool. So that's it for this part. If you enjoyed it, be sure to like, subscribe, and I will see you in the next part. Bye-bye.